Alright, so today, video 10, we're going to talk about limits, we're going to talk about direct substitution. And direct substitution happens on certain functions that are continuous within their domain. And we usually start with a list. So the most important thing we understand is that we're talking about continuous functions. Alright, so what kind of functions are continuous? And the easiest one is polynomials. Because if I make a graph of a polynomial, it is always continuous. It goes forever and ever. No matter where I look at a limit on this function, you're going to see that it is continuous. The value at that point exists. There are no infinite discontinuities, no jumps, no removables. Alright? So, again, that's where it's really important. Another one that's continuous are rational functions. And often students don't think about this. A rational function in its domain is continuous. Because we recall that here at A, this function, that A is not in the domain. Right now, for the function I put on the board, it's continuous everywhere. So if we look in spots, well, obviously it's continuous at that spot, and it has a limit. All right? So rational functions within their domain. All right? The next one I usually think of, personally, and I put them in the order I think of, is root functions. And again, it's not everywhere, but everywhere in its domain. So here's the square root of x. H of x is the square root of x. It is continuous from 0 to infinity, everywhere in inside its domain. And the last one is trig functions, and that includes reciprocal functions and tangent, but I usually think of this one, and it's continuous everywhere, but again, within their domain. As long as the domain is there, the function exists. And this is the simplest thing to check. Because, again, we have functions where we look at this, and it's the limit as x approaches 3 of x squared minus 4x plus 7. That is a parabola. I'm not 100% sure it's a graph of a parabola. And if I want to look at 3, the value here at 3 is just f of 3, and that's going to be the limit. You can tell that the left hand and the right hand are going to be the same. And I'm not going to do this for all the problems, but I could break it off in the limit laws. And I can plug in each part, 9 minus 4 times 3 plus 7. I see that this limit is, f of 3 is 4. Alright? Likewise, it doesn't have to be functions that are pretty. So I have the limit as x approaches 0 of sine of x plus cosine x. And if I graph that, it might look something like that. And here we see that it's a continuous function and a continuous function. Yeah, it's composite, but it exists. And at 0, we probably could find this value. So I plug in, and I simply can direct substitute here because it is continuous. So I get sine of 0 plus cosine of 0. Cosine of 0 is 1. So I get sine of 1 radians, all right, as the answer. And again, if you want to see this as a decimal, it's going to be like 0.7 something, but I'll just leave it as sine 1. And again, make sure you do your calculator in rads if you're going to do it this way. And these are both continuous functions. We just substitute in directly. This is one that often gets students because they look at it and they see x squared plus 7x plus 12, and they think to themselves, oh my gosh, I have to factor this. Don't waste time factoring. Does 3 make the denominator 0? It does not. A rational function is continuous in its domain. So this is a removable one. So at 3, you can simply find its value. And again, I love using the notation f of 3. You plug in 3, you get the y value f of 3. In this case, we plug in 3, I get 9 plus 21 plus 12 all over 6. And I can see that I get 30 plus 12, 42 over 6. The answer to this is 7. So for direct substitution, now, that's not a very interesting spot to think about. And often in your calculus courses, you're going to see professors and teachers not ask at 3. They're going to ask at negative 3. Or negative 4, actually. I'm sorry. Or negative 3. No, they're going to ask at negative 3. I'm sorry, negative 3. Because the top does factor into x plus 3 times x plus 4. And yeah, those cancel, and you get a value of 1. So this has a limit even if you change it. But again, direct substitution, we don't want to lose time with this, and we want to understand that when functions that are polynomials rationals, roots, and trig, and that you have a limit inside their domain, the value is simply going to be limit as x approaches a of f of x, just the value of the function f of a. And we're not going to waste time factoring or doing anything else. It should be the first thing we check with all limits. Keep practicing. Keep going.